Since Orville and Wilbur made their first flight at Kitty Hawk on December 17th in 1903, the aviation industry has needed mechanics, and not just any ordinary mechanic either. Simply put, they've needed the best mechanics known to man. The United States Air Force is no different. They've been seeking the very best aviation maintenance professionals since their inception. More specifically, one of the hardest maintenance jobs in the Air Force is that of a machinist or a structural repairman. These folks are tasked with making replacement parts for various aircraft, and they have simply mastered their trade. However, there has been recent advancements in one industry in particular that could be the biggest game changer this industry has seen since Orville and Wilbur made that first airplane. Digital printing has been taking the engineering and aviation industry by storm over the past decade, and current advancements are happening at a light-speed pace. I spoke with one of the United States Air Force's leading fabrication experts, Mr. William Nelson. Mr. Nelson is a foreman in the machinist career field, and he talks about the impacts that digital printing could have on the Air Force and how they do business in the future.
In the machining world, we typically take a 3D model or an IGES drawing of some type, and we incorporate that into a CAD system. Once it's in the CAD system, we have to program tooling, all types of tooling, end mills, drills, reamers, that type of stuff. This takes a lot of work, a lot of time, a lot of calibrating, a lot of setting up of machines and materials. Under 3D modeling and 3D programming, we'll take the same type programming criteria through the 3D CAD system and apply probably the same type of attributes we would for machining. From there, with minimal training and minimal time for machine setup, we'll be able to use a wider variety of materials to produce the same part with 3D scanning, 3D printing.
David Joyce, President and CEO of Gviation, talks about what 3D printing with additives can do for aircraft parts manufacturing looking toward the future.
I think what additive gives us is a whole different degree of freedom on how we think about component design. We no longer have to understand what the limitations of machining are and what the cost of those limitations are. So now we've taken many of those processes and been able to kind of blow them out with additive. That gives the designer a whole different palette of colors to paint with, and truly on a whole new canvas.
Greg Morris from GE Aviation discusses how they're putting these additives to work.
What's pretty exciting for the additive technologies is that we believe we have the capability to produce components and alloys that would be very difficult or if impossible actually to produce.
Mr. Morris goes on to explain how this new technology will replace the old machine welding methods.
In many regards, we look at this technology as replacing, in some instances, traditional technologies like castings or machining and brazing and welding. One of the exciting parts about the technology is we can combine multiple components that used to be brazed or welded together and make them into one single complex unit.